distribution. Alright? Poisson distribution is defined as a probability distribution which exists in time intervals. Remember that binomial distribution has to do with two occurrences, success and failure. But Poisson distribution is a probability distribution which exists in time intervals. Full stop. It relates to the probability of events. Which occurs within certain periods of time. It relates to the probability of events which occurs within certain periods of time. Which occurs within certain periods of time. Okay, so basically, when we look at Poisson distribution, there is a formula for it. All right, the formula for Poisson distribution is given as the probability of x equal to small x equal to lambda raised to power x e raised to the power of minus lambda all over x factorial. Okay, lambda raised to power x e raised to the power of minus lambda all over x factorial. Okay, now where lambda is known as mean of occurrence, lambda is called mean of occurrence. Okay, x is called probability determinant. Okay, so lambda is called mean of occurrence, x is called probability determinant. Okay, so this is the formula. To get the probability of x, you have to do equal to lambda raised to power x e raised to the power of minus lambda. This e is of course in your calculator. Alright, so e is not exponential, it's not 10 raised to the power. It's not. Alright, e is different from 10 raised to the power. Are we together? E is different from what? 10 raised to the power. Okay, so now let's look at an exercise where we have to apply this formula. Now remember, this is factorial. You know what factorial is? If you say 2 factorial, we are talking about 2 times 1. If you say 3 factorial, we are saying 3 times 2 times 1. More like decreasing to 1, multiplying by the decreasing values to 1. 5 factorial, 5 times 4 times 3 times 2 times 1. 10 factorial, 10 times 9 times 8 times 7 times 6 down to times 1. 2 factorial is 2. 3 factorial is 6. This is what we mean by factorial. Okay, just a recap for those of you who probably have forgotten what factorial means. Now look at this guy. The formula I said is lambda raised to power x e raised to power minus lambda all over x factorial. Are we together? Now let's look at an exercise. Take down quickly. Alright. Now given that in a telephone station, an average of 3 calls are made in 1 minute. Given that in a telephone station, an average of 3 calls are made in 1 minute. Okay? Now, determine the probability of the following. Determine the probability of the following. A. No call in 1 minute. B. This is an example question actually. A. No call in 1 minute. B. 2 calls in 1 minute. 2 calls in 1 minute. C, at least 2 calls in 1 minute. At least 2 calls in 1 minute. Then D, 1 call in 30 seconds. 1 call in 30 seconds. Okay? 1 call in 30 seconds. So we're looking at a probability where there is no call in 1 minute. You remember back then, although it's not so common these days, but back then, if you want to make a call and you don't have a phone, okay? You want to make a call and you don't have a phone, or you don't have a time, or maybe there is no light. There's usually a station where you go and make call and you pay. Okay? There are some persons that stay under umbrella, just like we have POS now. I don't know if you people grew up to actually see those kind of scenarios, but I met, my generation met that. Okay? Where you would have to go and pay and you make a call. They will tell you 1 minute is 25 naira. Back then, 2 minutes 50 naira. 2 minutes 50 naira. So how do they calculate it? When you're done making the call, they'll check the time. They'll check the time that you spent, and that's what you pay for. That's how it was. That's an example of a what? Telephone station. So we are saying that assuming that 3 calls are made, an average of 3 calls. Now an average of 3 calls here is the mean of occurrence. Is the what? Is the mean of occurrence. When you say, when you see a particular value, that you say, okay, 2 deaths in 1 year, or outbreak of 3 illnesses in 1 month. Do you understand? The time interval is not really your business. It is the number of occurrences, the average value of occurrences within that time interval that you should take cognizance of. Does that make sense? So if you say something like a man clears 20 forests in 1 day, all right, in 1 day, okay, the mean of occurrence there within 1 day is what? 20 forests. The only time that the mean will change is if the time what changes. For instance, in this particular question that we want to solve, what is the actual time? Talk to me. What is the actual time? 1 minute, right? But now if you look at the set of questions here, look at A, no call in 1 minute. B, 2 calls in 1 minute. C, at least 2 calls in 1 minute. D, 1 call in what? I think that the time has changed. So it is when we want to solve D that we will now make reference. To the time. That is when our mean of occurrence will change. We will now do something like, if 3 calls are in 1 minute, dash calls will be in 30 seconds. We will now get a new lambda that we will use in solving this. But let us proceed first. Let us proceed. So remember the formula is lambda raised to power x times e raised to power minus lambda divided by x factorial. Are we together? Alright. Now let's do this together. Okay, let's do this together. Now the first part of the question. Okay, let's use our parameters first. Now lambda is what? Is 3, right? Lambda is 3. Okay, lambda is 3. That's the major thing. Okay, lambda is 3. Now A is what? No call in 1 minute, right? No call in 1 minute. No call in 1 minute means that you're looking for the probability of x equal to 0. You're looking for a probability of x equal to what? 0. Because it's saying no call. No call is like 0 call. Are we on track? No call means what? 0. So now if you're looking for a probability of x equal to 0, then this now will be lambda is what? 3, right? So the formula is lambda raised to the power what? X, then e raised to the power minus lambda all over x what? Factorial. What is your lambda? Lambda is 3, right? What is x? 0, right? Times e raised to the power of minus 3. E raised to the power of minus 3 divided by what? 0 factorial. Divided by 0 factorial. What we are just doing is that we are substituting our parameters into the question. Okay? So as I'm talking, you're solving. You're using your calculator quickly, so we can be proactive. Now, this will now be equals to 3 raised to the power 0. Any 3 raised to the power 0 is what? 1. So this will be 1 times. What is e raised to the power of minus 3? What is e raised to the power minus 3? Quickly! Now, so we have 1 times 0.0497. After 9 is 7, right? Divided by 0 factorial is what? Is it 0? Is it 0 or 1? Check it now. 0 factorial is what? It's 1. There is no factorial that is 0. No factorial that is 0. 0 factorial is 1. 1 factorial is also 1. So this will now be 0.0497 divided by 1, and it will give you 0.0497. So this is our answer for the probability of x equal to 0. That is the answer. Okay? So now let's quickly go to the second one. What is B? What is B? 2 cos in 1 what? Minute. We will change lambda. Are we going to change lambda? Why? Because it's the same time. Good, beautiful. It's the same time. The only time lambda will change is when time has changed. Alright? So lambda is still 3. Now, but we are looking at for a probability of x equal to 2. So this will be, we have lambda raised to power x e raised to the power of minus lambda all over x factorial. So this will be lambda raised to the power x will now be 3 raised to the power 2 times e raised to the power of minus 3 divided by 2 what? Factorial. Are we together? So now this will be 3 raised to the power 2 is 3 times 3, which is 9. So we have 9 times e raised to the power minus 3 is 0.0497, right? Divided by 2 factorial. 2 factorial is what? Is 2 times 1, which is 2, right? Beautiful. So 9 times 0.0497 is what? 9 times 0.0497 is what? Is there a problem? 9 times 0.0497. What will we have? 0.447 what? 3. Now divide the answer by 2. What will you get? Divide it by 2. What will you get? 0.224. Let's just say approximately 224. Because it's 2236. Right? Yes. Okay, beautiful. So now let's quickly delve into the next one. The next one is what? C is what? C is what? At least 2 calls in 1 minute. At least 2 calls in 1 minute. At least 2 calls in 1 minute. Now look at this, guys. Whenever you are doing any probability distribution and you say at least, alright, at least you use greater than and equal to sign. At most you use less than and equal to sign. At least greater than and equal to. At most less than and equal to. So you say at least 2 calls means you're looking for a probability of x greater than and equal to 2. What does at least mean? At least means that the lowest number of calls is what? 2. But please, you should not exceed your lambda. The maximum number of calls here is what? 3. Maximum number of calls here is what? 3. Alright? Just like in binomial distribution. the number of occurrences should not exceed n. Like in our class when we were looking at binomial distribution, we looked at 12 TV tubes, right? And we are saying what is the probability that 4 are defective, at least 3 are defective, at most 4 are defective. You realize that we do not exceed 12. When it comes to binomial distribution, don't exceed your sample size. When it comes to Poisson distribution, don't exceed your mean of occurrence, your lambda. Are we together? Alright, so now look at this guy. So when we say probability of x greater than or equal to 2, we are saying that we are looking at from 2 to 3. We are saying probability of x equal to 2 plus probability of x equal to 3. That's it. At least means from that value to the highest value. At most means from 0 to that value. At most means that if it were to be at most 2 calls, it would have been probability of x less than or equal to 2, which means that the highest value should be 2. You're talking about the values that are less than 2 and equal to 2. So at this point, you now have to look for the probability of x equal to 2 and the probability of x equal to 3. You add them. Luckily for us, we already have probability of x equal to 2, right? Thank you. So you don't have to stress yourself to start doing probability of x equal to 2 again. So this will just simply be probability of x equal to 2 give us what? 0.224, right? Plus, now probability of x equal to 3 is what we will solve. Remember, our formula is lambda raised to power x, 3 raised to power minus lambda over x factorial. Alright? So now, it means that our lambda remains 3. X is raised to power 3 times e raised to power minus 3 all over 3 factorial. 3 is everywhere. You can see 3 is everywhere. Just a coincidence. Alright. So now this will be 0.224 plus, do this guys. This will now be 3 raised to power 3 times 0.0497, right? 0497. E raised to power minus 3 is what we have been using since. All divided by 3 factorial. 3 factorial is 3 times 2 times 1, right? Good. So it means that here would have 0.224 plus 3 raised to power 3 should be 27. Am I correct? That is 3 times 3, 9. 9 times 3, 27. So it should be plus 27 times 0.0497 divided by what? 6. Divided by 6. So this will be 0.224 plus 27 times 0.0497 will give us what? Will give us what? 19. That will be divided by 6. Now divided by 6. So it will be 0.224 plus what? 0.223. Please confirm it, another person. 1.3419 divided by 6. 0.22 what? 0.22 what? I've been telling you guys, be careful of approximation. I don't know why you'll be saying 0.2236 and you'll be telling me 0.223. 0.223 what? 65. Please be very conscious of approximation. Be very, very conscious. It can change your answer entirely. So now the final answer, probability of x greater than or equal to 2 will give us equal to what? Add this value, what will you get? What will you get? 0.what? 44.765. 44.765. Alright, so these are approximately 0.45. So this is our probability of x greater than or equal to 2. Alright? So now let's quickly look at the last one. One call in what? 30 seconds. One call in what? 30 seconds. Okay. One call in 30 seconds. Now, if you look at it very well, you will now realize that we have a different time. I told you that lambda will only change when time has changed. When time has changed. Alright, that is when lambda will change. So now look at this, guys. We had lambda before to be 3 calls in 1 minute, right? So you say 3 calls. 3 calls. Now we say, look at what we're going to do now. We say if 3 calls equal to 1 minute. Now this time around, because we have 30 seconds here, we will not write it in minutes, because if we write it in minutes, it will not be easy. It will not be what? Easy. So what do? We'll change this 1 minute to seconds, so it will be what? 60 seconds. So this will be, if 3 calls is equal to 60 seconds, x will be equal to 30 what? Seconds. X will be equal to 30 seconds. So we need to make x in the formula. So it means that x will be 3 calls times 30 seconds divided by cross multiply. This time it is divided by this. 60 seconds. Seconds will cancel seconds. 30 here 1, 30 here 2, right? So we have 3 times 1, 3. 3 over 2 is what? 1.5. So this is 1.5 what? This is 1.5 calls. That is half calls. Okay? That is half calls. No, it's more than half. It's 3 over 2. 3 over 2 could not half. Half is 1 over 2, which is 0.5. Okay, this is 1.5. That is half of 3. Okay, the something we could have easily said, okay, half of 1 minute is 30 seconds, it means that half of 3 will be 1.5. But it's good for us to calculate it like this. So in subsequent cases where we have questions, like we will not just be doing our stuff based on assumptions. Alright, let's quickly solve this. So it means that we have gotten a new lambda to be 1.5 watts. 1.5 calls. So now, in 30 seconds, lambda is equals to 1.5 calls. 1.5 calls. So it's 1.5 we're now using solving for 1 call in 30 seconds. So now look at this guy. So probability of x now will be equals to 1. Okay? So it means that we will now have, remember the formula is still lambda raised to the power of x. Okay, this is now 1.5 raised to power what? 1 times e raised to power of minus 1.5 divided by what? Divided by what? 1 factorial. 1 factorial. Alright? 1 factorial is still 1, right? Good. So 1.5 raised to power 1 is still 1.5. Times, what is e raised to power minus 1.5? Someone was supposed to have been doing this when I was right. Sorry? This is 4.48. Okay? Now divided by 1 factorial is also what? Is 1. So just do 1.5 times 4.48. Are we sure of this 4.48? What is it? E raised to power minus 1.5. Sorry? 0.2231. Okay? 0.2231. So 1.5 times 0.2231 will give us what? 1.5 times 0.2231 will give us what? 0.33 what? Are you sure of this? Please, someone should confirm it to the calculator. 4 what? 465. So these are approximately 0.335. So it means that this is the probability of x equal to 1 for 30 seconds. Alright, so now let me quickly give you an exam question. Okay, now please take down. Please take down. Please take down. Now, in a certain teaching hospital, an average of 12 deaths, like DATHS, an average of 12 deaths are recorded. An average of 12 deaths are recorded for prostate cancer cases. For prostate cancer cases in 10 months. In 10 months. All right. Full stop. Determine the following probabilities. Determine the following probabilities. A, 5 deaths in 10 months. Have you written that? A, 5 deaths in 10 months. B, at least 3 deaths. At least 3 deaths. Okay, in 6 months. At least 3 deaths in 6 months. Then C, at most 5 deaths. At most 5 deaths in 7 months. At most 5 deaths in 7 months. So please attempt these exercises. Okay, these are very key exam questions on, of course, Poisson distribution in any statistics examination whatsoever. All right, so master it, solve it, master it. Okay, if you've not subscribed to this channel, do well to hit the subscribe button, like as well, share. If you have any question whatsoever, ask a question in the comment box. This exercise I've just given, also write your answer in the comment box below, and of course, you'll be answered. All right, take care.